Okay, so kind of the main thing that we want to keep in mind, and composite figures are also called irregular polygons. Okay? They're also called irregular polygons, meaning they don't really have a regular shape. They could look a little different. So we can find the area of an irregular polygon by breaking it apart into simpler shapes. Okay, we can find the area of an irregular polygon by breaking it apart into similar shapes. All right, so go ahead and jot this one down and draw it on your paper. Okay, that's what we would call a composite figure or an irregular polygon. It doesn't really fit into the categories that we've seen before. It's not a square. It's not a rectangle. It has, let's see, 1, 2, 3, 4, 5. It has 6 sides, but that's definitely not a hexagon. It doesn't look like one. It's not a triangle or a trapezoid, so that's what we would call a composite figure. And like Andrew said, it's made up of different shapes. So what 2 shapes do you see that have come together to make that 2 rectangles, right? If you do kind of a dashed line here, you can see there's 2 rectangles that have been kind of pushed together. Okay? So this right here is our composite figure. So they want you to find the area of that thing. Okay? So obviously to do that you need some measurements. So let's go ahead and jot some of those down. Alright, so we've got our composite figure, and in order to find the area, we want to break it apart into 2 different shapes. So when we do that, instead of these being connected, we're just going to break them apart. Okay? Now it's pretty clear, we can still see the measurements for this rectangle here. It tells us that the width is 1.5 centimeters and the length here is 1.8 centimeters. And what about this small one? What's the length, Araya? 2 centimeters. And what's the width? Favorite? 0.5 centimeters. Okay. Now that looks a little bit more manageable. So instead of having one composite figure, we've broken it up into 2 rectangles. Okay, so do we know how to find the area of a rectangle? Yeah. What's the formula to find the area of a rectangle, Jimmy? Well, That's just telling us that the whole bottom length is 3.5 centimeters. So when we break it apart, it's getting kind of split in two. So one part of it was 1.5 and the other part was 2. Yeah, it's a good question there. Okay. Okay, so can someone tell me the formula to find the area of a rectangle? So Carla? It's going to be length times width. So go ahead and write it. Area equals length times width. Let's go ahead and label these shapes so we can keep them straight. Let's just label them A and B. Okay, so what do you think we should do first? Alright. What do you think we should find first? Okay, we know all the measurements. Remember, we want to find the area of this entire composite figure, so what should we do first, Grace? Sarah Alice, what do you think? Yeah, let's find the area of rectangle A first. Okay, so we're going to find the area of rectangle A first. Okay, so what is my length? What's my length? Remember, the length is the longer side. So we have 1.8 times the width, which is what? 1.5. And when I multiply that together, what do I get? 2.7 what? Centimeters squared. Okay? Now, am I done? No, what else do I need to do? I need to find the area of rectangle B. Okay? So I found rectangle A. Now I've got to find rectangle B. Okay, so do we use the same equation or the same formula or a different one? We'll use the same formula. It's still a rectangle. But what are we going to multiply together this time? We're going to do 2 times 0.5, which should give me what? 1. Thank you. 1 centimeter squared. Okay. So what's my final step? What do I need to do last to find the area of this composite figure, Brennan? Yeah, you add them together. Because remember, we didn't turn this one shape into 2 shapes. We just broke it apart so we could find the area of each shape, but they're still part of one shape, right? So it's not 2 separate shapes. They've got to come together. So we're going to add 2.7 plus 1, which will give us what? 3.7 centimeters squared. So that would be the area of this entire composite figure. Okay? Are there any questions on that? So, starting from the beginning, what was the first thing we needed to do? Yeah, we split it apart into 2 easier to work with shapes. Okay? What do we do after that? We found the area of both shapes, right? Then what do we do? Mm-hmm. Yeah. So you'll break apart your shape, you'll find the area of both shapes, and then you'll add their areas together to get the area of the composite figure. Okay? How are we feeling about that so far? Thumbs up in the middle or thumbs down? Okay. I don't think I see any thumbs down, so that's good. All right. So I'm going to flip my page over, and we're going to look at another composite figure. Go ahead and draw that shape. Now this line right here is just an arrow pointing outward. So it's not like part of a weird part of the shape. It's just an arrow. Okay? As you're drawing it, the shape it looks like a combination of what two shapes? Yeah. Looks like a triangle and a rectangle pushed together. I'll give you a minute to draw that. Okay, so easy question. What type of shape is this? Two names, two different names it could have. Composite figure or, yeah, either one. I'm going to just go with composite figure. Okay, so there's my composite figure. So I agree that it does look like a rectangle and a triangle got kind of smushed together, because if I do a kind of dashed line right there, I can see those two shapes that have been put together. Okay? All right, so let's put some measurements on this thing. All right, so we've got some measurements. And what did we say we were going to break it apart into? A rectangle and a triangle, right? Still the same shape, just split apart. All right, so we've got to record the measurements of the rectangle. And I know mine looks very much like a square, but let's say that this side at the bottom is the length. What's the measurement of the length of my rectangle? Brandon? It's not going to be 13. This 13 goes from the tip of this point here all the way down here. So what's my length? 10. It's 10 centimeters. What does this 13 represent in this composite figure? The height, yeah. Okay, so if my length is 10 centimeters on the rectangle, what's my width? Skylar? 8 centimeters, good. Okay, that one was pretty easy. Okay, what about this triangle though? What's the base of the triangle? Grace? So this is going to be my base right here. Yeah, it's 8 centimeters. Whoa. Okay, because these are the same length, or the same measurement. But what about the height? Caleb?
3 centimeters.
How did you know it was 3 centimeters?
Because we used the 10 centimeters on the bottom.
Uh-huh.
10, so that worked out to 3.
Right. Good. Does everyone see how we got 3 centimeters?
No.
Okay, so if you look at this shape, this whole thing right here, this whole line is 13 centimeters. When we split them apart, this much of the line is how much? 10 centimeters. So if the whole thing is 13, then how much should this be? 3. So that's all you did. Is that clearer now? Yes, no, maybe? Okay. All right, so now that I've got my shape split up, what do I need to do? Well, I need to find the area of what? I need to find the area of both shapes, right? So this is a rectangle. So what's the area, or the formula for the area of a rectangle? Length times width. Those need to be quick, okay? What about the area of a triangle? Sarah Alice? Base times height divided by 2. Good. All right. So to find the area of the rectangle, what would I plug in? 10 times 8, which would give me what? 80 centimeters squared. Get in the habit of giving me that completed answer. Okay, now for the triangle. Once I plug everything in, what's it going to look like? Eight times 3 divided by 2. Then I need to multiply. What's 8 times 3? So I'd be left with 24 divided by 2. Thank you. 12 centimeters squared. All right, so that's the area of the individual shapes. Hudson, feet down. So how do I find the area of my entire composite figure, Caleb?
You add the 2.
Yeah, so I'm going to add 80 plus 12, which should give me what? 92 centimeters squared. Okay? Caleb.
Why do we do the first one and this one because they're different.
Well, let me rephrase this question. So I think you're asking, why did we use different formulas for the first one? So let's look at the shape. When we split up this composite figure, we split it into 2 rectangles, right? So we used the formula to find the area of a rectangle. But on this one, we split it into a rectangle and a triangle. So you've got to use the area, or the formula for the area of a triangle on that one. Yeah. So it all just depends on what shapes you're going to be splitting it into. Okay? Any other questions?